In Chapter 6, we're going to study linear functions. And we're going to build off some of the properties we learned in Chapter 5 on linear relations. Here's a list of some of the new vocabulary words we'll learn throughout this unit. All right. Reminder, for a linear relation, we can calculate the rate of change as the change in the dependent variable divided by the change in the independent variable. And this is commonly referred to as the slope, and we talked about that in Chapter 5. And slope is rise over run, or we can use the formula y2 minus y1 divided by x2 minus x1. Now in calculus, we'll do a lot dealing with slope, and lots of times we'll be talking about slope of tangent line and slope and secant line. So slope is a very integral part of calculus, as you will find later on. All right, in this first section, we want to calculate the slope of each line segment. Now, for this particular question, for part A, we could use the endpoints and we could figure out the rate of change going from A to B. Or if you can find another point where the graph crosses right in a nice corner, like right here, you can also use that point in B to find a rate of change. So if we use this point, okay, the change in the x direction, I'm going from -1 to 4 would be 5. And my change in the y direction, I'm going from 0 to 3. So my rise is 3. So my slope would be change in y over change of x, which is going to be 3 over 5. For part B, again, I could use this point right here, and this would be my change, my rate of change. So my change in y, I'm going from 4 down to 0. So since I'm going down, would be -4. My change in x, I'm going from -3 to -1. My change is 2. So my rate of change is -2. All right, when we talk about zero slope, okay, first of all, positive and negative slope. Positive slope is if as the x values get bigger and my graph is increasing from left to right, it's going uphill, then I have a positive slope. If my graph is going downhill, I have a negative slope. Zero slope is the slope of a horizontal line. So if my line is horizontal, the slope is 0 because my change in y is 0. Undefined slope, because in this case my change of x is 0, so I'm going to have some number divided by 0, which is undefined if I tried to calculate that slope. So a vertical line has a slope that's undefined. Okay, we want to draw a line segment. First of all, it has a slope of 7/5, so we're going to start with any point down here, say, in my rise. This is my change in y. This is my change in x. I'm going to go up 7 and over 5. And I'm going to join those two, and that would be my line segment with a slope of 7/5. For a line segment with a slope of -3 over 8, I'm going to start right here. I'm going to go down 3, and I'm going to go over 8 right there. And again, I would join those two. That would be my slope, or a segment with a slope of -3 over 8. So in the next example, I want to determine the slope of the line passing through -5 and -3, which is right here, and 2 and 1. Again, I'm going to use a slope formula this time. So I'm going to call that point x1, y1, and this one x2, y2. So if I'll calculate the slope, it's going to be y2, which is 1, subtract -3, and I'm going to divide that by x2, which is 2, subtract -5. So this works out to be 1 subtract 3 is 4, 2 subtract -5 is going to be 7. So my slope is going to be 4 over 7. Okay, then distance application, we're just going to skip that section for today. Let's take a look at the following linear equations, and we're asked to find the slope. Well, once we get the slope in the form y equals rate of change x plus the y-intercept, so we got to isolate y. The value in front of the x term is my slope. So in this particular case, my slope is 4. Question B, I have to get y by itself. So to do that, I would have to divide every term by 2. So in this case, I'm going to get -3 over 2x plus 5 over 2. So this is my slope. My slope would be -3 over 2. Question C, again, I want to isolate y. So to do that, I am going to add the 4x to the other side and subtract the 9. So now I'm back to a question like B. Now I'm going to divide everything by 5. So y is going to be 4 over 5x minus 9 over 5. So therefore, my slope is right here. The number in front of my x term, which is going to be 4/5. Now in my last example, I want to get rid of my fractions first. So I'm going to multiply everything, first of all, by 12. So 12 times 3 divided by 4 is going to be 9y. 12 times 2 divided by 3 is going to be 8x. 12 times 3 is 36. And 12 times 0 is 0. So now I'm back to a question like C. So I want to get the 9y by itself first by adding the 8x and subtracting the 36 over. And now I'm back to a question like B. So now I have to divide by 9. So I'm left with y is equal to 8 over 9x minus 4. So my slope is the value in front of x. So in this particular case, my slope is 8/9. Okay, let's take a look at our last example here. We have Yvonne, who's recorded the distances she traveled at certain times since she began her cycling trip. What is the slope of the line through these points? So again, if I was to look at my rate of change here, my change in the y would be 24, and the unit is kilometers. My change in x is 1 hour. So my slope is going to be change in y over change in x, which would be 24 kilometers over 1 hour. So what does my slope represent? Well, what quantity is kilometers per hour? And I'm sure most of you know that that is speed. Speed is kilometers per hour. And now how can we use this answer to be from part B to be used to determine the following two questions? How far Yvonne traveled in 1 3/4 hours, and the time it took Yvonne to travel 55 kilometers. Well, it would make sense if we first came up with an equation for our distance. Well, our distance is equal to our rate of change, and we said that our rate of change was 24 times h plus the y-intercept. Again, the y-intercept, if I draw my line in here, the y-intercept is 0. So my equation is just d equals 24, and it should be t instead of h. Okay, so for Roman numeral 1, they want to know the distance. Our time was 1 3/4 hours. So 1 3/4 is really 1.75. So if we get our calculator, 24 times 1.75 is going to equal 42 kilometers. And in part 2 of C, they want to know the time it takes you to travel 55 kilometers. So I'm going to put 55 in place of D. So 55 is going to be 24 times T. I'm going to divide both sides by 24. And my time is 2.29 hours would be the time that it would take for her to travel 55 kilometers. Okay, that concludes section 6.1. So if you have any questions to these questions about the answers to these questions, just search the website and you'll find the answers there. Okay, all the best.